Subject name Digital Electronics, Unit 1, Digital Fundamentals. Um, for second year PC and Mechatronics, that is some. And myself, I'm Abdul Rahman, working as the assistant professor in the Department of ECE in MAMSE School of Engineering. So these are the syllabus under NNST. Unit 1, Digital Fundamentals. Unit 2, Combinational Circuit Design. And Unit 3, Synchronous Sequential Circuits. And Unit 4, Asynchronous Sequential Circuits. Unit 5, Memory Devices and Digital Integrated Circuits. So these are the textbooks. Uh, that is Morris Mono, the textbook. So fifth edition version. Then reference book also they listed. So in that the reference book, first one is Charles Achro, Thomas, and third one the Salivaganan. So maximum reference get it from that Maurice Mono and Salivaganan, and then Unit 1, Digital Fundamentals. So digital electronics. So before we start uh, that basics of what is digital. So we know that before digital there is a analog signal. The analog signal is nothing but it's a nature. So nature of the signal that they are used for all the electronic devices. But the problem is that analog signal also is good, but it's not very accurate. Also, it is not um, good for best. It is not good for communication. That means it is also good, but it's not much more good because it has some kind of noise affected easily. So that's why we are going to use digital electronics. So digital electronics, it's zeros and ones. One is low, otherwise it is high, zero or one. So we have to use nowadays we have to use maximum digital electronic. They used the previously when we go to the theater somewhere in electronics thing, when you hear or read anything that won't give accurate. Even if you go the theater, the sound some extra sound will become. But nowadays the digital surround system, the accurate sounds it will be produced because of this digital uh, this digital these are the application also we are used in digital systems, industrial process control, military system, television, communication systems, medical equipment, radar and navigation. So there also we are using digital systems. So the digital system, if you're going to see, before that they given about signal. So what is signal? Signal is a physical quantity. It contains some information that is called as signal. And signal having two type of classification. One is analog signal, another one is digital signal. So just now we discussed about analog. So analog is a nature signal. It's a continuous time signal. And real world scenario they have observed from nature. That is analog. So examples for analog signal. So temperature, pressure, distance, sound, voltage, current, power. So these are examples for analog signal. Also the graphical representation for analog signal. It's a continuous time signal. So see there is a x-axis on the y-axis. So x-axis is a time period, y-axis is a temperature. So consider the daytime temperature. That means See, there's a time. So when the morning time, the temperature is something there. Then when is that during the time running? After that, the temperature is increasing during the lunch time. That means afternoon time you will be getting peak. Then it is reduced. Then the day again started. Then it is increased like that. The graphical representation of temperature is shown like that. So this is an example for analog signal. Okay. Then the circuit that process analog signals called analog circuit system. The example for analog system is a filters, amplifiers, television, receiver, motor speed controller. So examples for analog system is filter, amplifiers, television, receiver, motor speed controller. And drawback of analog system. Yeah, we know that it is not a digital oriented, so it's less accuracy, less versatility, then more noise will be affected in analog system and more distortion automatically when the noise is more automatic distortion will come. Also it affected by weather. So far we've seen about analog system. Now we are going to see about digital system. So digital is finite number. So there it is continuous time signal. Here it's a finite number, distinct value. So not continuous time signal. So digital electronics, that calculators. So these are the example for digital electronics. Electrical signal. So we know that there are low and high signal only is there. So low means it's zero, high means it is one. That means low means grounded or high means 5 volt. So there are two types of signal only present in digital electronics. So this is a graphical representation of digital signal. So binary number 0 or 1. So x-axis time period is running and y-axis they put it as voltage. With the maximum voltage 5, that is 1. Otherwise it will go to the 0 volt. So there are only two level. So 0 or 1. So the circuit that process the digital signals are called as digital circuits. So example for digital system. So registers, flip-flop, counter, microprocessor. So all are example for digital signal systems. An advantage of digital system, it's compared to analog, it has more accuracy, more versatility, and less distortion, easy to communicate, and possible to store information. So these are the advantage of digital system. And finally, we have the comparison of analog and digital system. So this might be asked to mark. So analog signal has a infinite values, and digital system they have finite number of values. So analog signal is a continuous time. It's a nature signal, and digital signal has discrete in nature. So analog signal is generated by transducer and signal generators. So digital signal is generated by analog to digital converters. So example for analog signal is a sine wave, triangular wave. Example for digital signal, it's a binary signals. So this is an example for analog and digital signals. Okay. So number system. So far we've seen about analog and digital, so everything. So now we are going to see about number system. A digital system can understand the position of number system. So decimal number system. So decimal number system that we use in our day-to-day life. So that is a decimal number system. So decimal number system have the base is 10. So base 10 means the digits started from 0 to 9. So total count is 10. So that way the base is 10. Then the decimal point is represented is units, tens, hundreds, thousand, and so on. So, so this is the way they have to mention in decimal number system. Okay, thank you.